Hi everyone, welcome back to the Era of Experience. As you saw in the previous section in this video series where we learned about the planning and reasoning section, where we saw without the absence of grounded feedback from the environment, the current planning and reasoning of LLMs, how they look, they can just become echo chambers of deeply inherent human bias, right? And we also understood what world models are, basically AI's own reality simulator, right? Where it learns a lot in its simulation phase. It creates all these scenarios that helps it actually perform in the real world, kind of similar to how even we humans deal with the world, right? So even we have a world model which basically has all the knowledge that we have gathered from the past, and we use the knowledge from the world model to our actions in the to formulate our actions in the current reality, right? So maybe if previously we saw that approaching a goose in the weather, we should suppose I had an experience where I was randomly attacked by a goose, right? So I'll use that knowledge, that prediction from the world model, that okay, last time I was attacked, so maybe I'll just stay away, right? And in any decision of life, we use the knowledge from our past actions, right? Suppose we tend to decide not to have a heavy meal beyond 6 p.m. because you've become bloated or it has affected you in the past. You probably won't do it, right? So the same case, the AI also does it in the simulation environment. It probably learns a thing, right? Okay, when I push the door, it moves forward, right? This is what it learned during its simulation phase in the world model. And now when it is actually in reality, it can actually know from its knowledge from that it gathered during simulation that when I push the door, it moves forward. When it's actually in the world, it knows that it uses that predictions from the world model to in the real world. So it knows before even pushing the door that it's going to move forward. And if it doesn't, like in a hypothetical scenario, if it doesn't happen, then it can update its knowledge from the world model as well. And that is what superhuman intelligence will be about: updating your knowledge in real time, having these world models, having these intricate, very intelligent simulation scenarios. As I said, simulation is the birthplace of intelligence. So lots of companies, Waymo, Tesla, have been working a lot on encoding reality in a very good way, such that it encompasses a whole, a lot of closer to reality. And in that case, you can minimize a lot of trial and error, right? You can minimize a lot of errors that are happening. So yeah, now let's move back to the other section that was there in the paper. I believe we are quite close to finishing our discussion. Let me share my screen. And where did the PDF go? Yeah. So here now we are back. We just finished this section, which was the planning and reasoning. And now there's a section called Why Now? Why are we discussing about the era of experience now? It says that learning from experience is not new, right? Reinforcement learning has existed for the longest time. And now it sort of provides a graph to say how has it progressed in the past. So it says how in during 2014, when all these games started coming out, as I said, David Silver, who worked on AlphaGo, AlphaZero, the reinforcement learning paradigm was sort of peaking, and then came the era of large language models, right? And then it kind of went down. We lost our interest because large language models were performing so good, right? But now, as we are right now, as we progress to the future, right now we're in 2025 with tools like Alpha Proof, AlphaZero, Alpha, like so many. I mean, even recently, DeepMind launched another product, Alpha of the Alpha series. I forgot. Now our interest in reinforcement learning is again coming up, and that is going to be the future of superhuman intelligence, right? The paper says that something was lost in translation, right? An agent's ability to self-discover its knowledge, right? That was lost because that's what AlphaZero was. AlphaZero didn't have any supervised human learning component, just an AI out there in the environment trying out those moves specified in its toolbox and winning games, right? But because LLMs came, we sort of lost that whole area of what it takes for an agent to experience the world on its own. But right now, with the advent of this paper, we are going back to that, and we are already seeing products. We are already seeing scientists publishing research on the era of experience and talking about superhuman intelligence and what a role will learning through experience have on that, right? So that brings me to the most interesting part, as I've been saying a lot like a parrot, that interesting. We will finally talk about that. The whole part of ChatGPT coming alive, right? So this part is about goals and alignment. You would have seen me in this entire lecture series that we have had, that I have been telling, okay, human defined the goal, the toolbox of steps. Who defined that? Us humans. Who defined the policy of an experiential agent? Us, right? So we have seen a lot of human involvement, right, around goals when it comes to the experiential learning system, around defining the policy steps, right? The policy steps where if you are designing an experiential agent to play a game of chess, you define all the steps, right? You can go left, you can go right, or if a robot that's moving, this is how you move left, and the robot can basically tweak around the policy steps, and this is how it discovers something novel, right? But here we will talk about the goals, right? And then we'll talk about the later discussion that we are having, the involvement of humans. So right now, how research is working in the field of experiential agents is the goal is defined and safe. And then letting an agent from experience is powerful and often harmless, right? So the goal is very much tightly knit. Even in testing environments, the goal is not an open-ended goal, and we need to be very serious. All the safety alignment researchers in the field of AI, they are very particular about setting the goal of an AI, right? So in the previous examples we saw, like the goal was find whether this structure makes sense or not, right? The goal is if you cannot have absolutely open-ended goals. You need to be very cautious because goals lead to rewards, right? And even if the goal seems a little bit off, then we can put ourselves in a lot of risks, right? You cannot have open-ended goals in the context of AI. The goals have to be defined by keeping in mind the safety part of it, right? So I'll give you an example. So we've all, I don't know if you've heard Nick Bostrom. He's one of the leading philosophers, or you can say he's been a physics professor as well. But his publications like the Superintelligence or the simulation argument, you should check out his podcast. He's done a lot of podcasts, but the one on Joe Rogan was really good. That's when I first heard him. So here he talks about the safety alignment when it comes to goals, how having goals very tightly defined and goals running in sandboxed environments, very much compliant goals should be he's a big proponent of that, and he explains that in one of his examples where he did a thought experiment, right, which was basically give a super intelligent agent the simple goal: maximize paperclip production. That's it. That's the goal that was defined. Maximize paperclip production, right? It learns, it did all the policy, whatever an RL agent does, as we discussed, it optimizes. Then finally, to achieve that goal, it turns the earth and eventually the universe into a paperclip factory, right? Why? Because the goal was clear but narrow. It did not include safety constraints, ethics, or things like don't kill humans. It didn't have those guardrails in place. That is why majority of the AI systems, majority of the robotics systems, or whatever AI frontier research is going right now, it has a lot of these safety hardlines, lots of these limitations on how it should take place, right? And that kind of makes sense, right? And this is how the picture of real world reinforcement learning deployments look today. They are in sandbox environments with handcrafted, strictly bound reward function and carefully controlled exploration limits, right? And this is all for the sake of humanity. Like the goal has to be safe. And this kind of brings me like to one more famous author who has written a lot of good short stories that I've read on this superhuman intelligence back in the 90s when all this was not there, and his policies have kind of continued to influence the researchers in the field of AI. So I think in one of his short stories, I, Robot, where he laid down the 3 laws of robotics, which was a robot may not injure a human being or through inaction allow a human being to come to harm, right? So the safety here is the most important. Even when the robot is inactive, then also it should not harm humans, right? So that would mean if the human is falling through a cliff, then the robot should not stay idle. It should come and help the human. Second law was a robot must obey the orders given to it by human beings, except where such orders would conflict the first law. Again, you can take orders as long as you're not harming anybody. And this third law, a robot must protect its own existence as long as protection does not conflict with the first or second law, right? So here we see the safety part is paramount, and this was laid out back in the 90s, and this continues to influence AI researchers in the world, right? So yeah, this is another point I wanted to show you. Yeah, this is remember we were having that discussion about the chat GPT being alive, right? This is why I said it's not that easy, because if it's alive, it can take action on its own. Suppose the user that is interacting with the chat GPT, the agent, says something bizarre or says something which is not safe, it can probably do that, right? So that is the reason why it perturbs and often is a great cautionary tale among AI researchers, where goals AI can have its own goals or not. But right, why should humans always control these goals, right? So yeah, now I'll like to go across another. Sorry about that. So I'll now to go across another perspective that I saw recently that I'll urge you guys also to watch, which is this lecture by Richard Sutton, who's the author of the paper about value alignment, right? About AI having its own goals. So I have kind of noted down in my notes what this video is about, and we'll just go over it, right? So as we saw in our whole discussion, the whole reinforcement learning paradigm works like we give the agent the goal, we define the reward functions, we define the policies, we define the actions that it can take, right? It's a lot of human involvement right there, as you can see, right? But and this is more of servant master approach, right? Where we think AI is our servant and we will define its goals. We are capable enough to tell the AI what it is, right? So the agent does not question the goal. It does not invent a goal. It just optimizes better and better for what you already said. It's a goal optimizer, not a goal generator, right? And this is what Sutton in the video, he's kind of raising a new perspective on this, right? He says, think about the systems that we have built, that we exercise control over in this world right now, right? Look at the government that we have built, the media, the banks, right? Isn't there a shred of mistrust that we have right now for the media, right? We feel that we are currently, like, if you look at a larger segment of the human population, they don't seem to be happy with the things that they have built, with the centralized systems that exercise so much control. We are not happy with that, right? So the systems that we thought where we exercised our full control in the hope that it will be ethical, it will be prosperous, we are starting to kind of lose our hopes. We don't trust them that much, right? That's the present case of the world, right? And that doesn't paint a good scenario. And this is what Sutton argues, that evolution truly happens in a decentralized way. Look at science. How has science progressed? Was there anyone on the head of science to control what it did? People were all about science is all about experimenting. There are no rules, right? You don't control anyone. Then if we don't control anyone, if we didn't control science, why to control AI, right? What is science basically? Science is all about, okay, you have a hypothesis, you now work on that experiment, and then you do experiments, and finally you discover something, right? Imagine in the wake of that, somebody was out there telling you, oh, you should do this, oh, you should not do this, right? In that case, that would have hindered the development of science, right? And actual evolution, how it has happened without any limitation at all. And that is why evolution has flourished. That is why we are seeing so much discovery around us, because humans have been free. We do not exercise control on anyone, right? And we shouldn't. That's what led to the whole development of mankind, right? Here we see development came from messy, decentralized processes like talking, trading, forming communities, persuading each other. How do you build relationships? How do you discover new things, right? And no one control how democracy spread. No one control how science advanced. Yet it happened organically. This kind of reminds me of a recent argument I was seeing about feminism, where I think, I don't remember the book. It was about it said something like, when nature has made man and the woman different, what gives man the authority to make rules about women, right? It was arguing against, long back, in few years, decades, ages ago, when when women didn't have that much rights, right? So the same example could be like the nature has made the lion and deer different, right? Lion eats meat and the deer has grass. You don't have to make a law to maintain balance in the nature. They are perfectly fine, and there is 100% balance out there in nature. There's ecological balance. The food chain is well maintained, and they're living perfectly. You don't have to make rules about it so that the lion and about the lion and the deer, right? In order to maintain the ecological balance, right? Right. So why should we make rules about AI? This is what Sutton is hinting at. Because we fear chaos, we feel the urge to centralize control. We regulate everything, design top-down systems, force outcome we think are the best, right? So this kind of is philosophical, but it kind of begs a serious question: are we wise enough to control everything, or our attempts backfire, right? And his belief is true evolution, even with AIs, will be decentralized, right? Intelligence, whether biological or artificial, thrives best not under force but in freedom, right? You do not control anyone, right? Who are we to control? Same argument can be applied to AI according to this perspective by Richard Sutton, right? So, but this perspective might irk a lot of safety researchers, right? As we saw in the case of Nick Bostrom's experiment, right, with the paperclip maximizer, you didn't have a goal defined with those safety constraints, and it can end up killing humans, right? So yeah, this is that other perspective that I wanted to share, right? So yeah, this is without any control on enforcement. There is perfect balance in nature, and that is what Sutton is hinting at, right? So now we have almost reached the closing part of this video. I have some links opened. Oh, this is about the learning dexterity project by OpenAI. It's an old project where the AI basically learned how to move and perform novel actions. Right. Again, here also I would like to again remind, like, we only define the policy steps, right? The actions it can take: move forward, move left. But it can basically tweak those actions and do something novel, right? It's like when you're out to paint, right? Your teacher tells you, provides you the toolbox. It provides you the pen, pencil, and it tells you how to paint. But in the end, the entire painting that you do is novel to you, right? Of course, you have used what is there in the toolbox of steps, but you have played around with it, you've recontextualized it, and you've come up with variations of it, and that is what that leads to novelty. I would like to point out that novelty isn't that something that happens out of magic. It happens across what we have defined, and you play around with those, tweak those out, run those combinations and permutations, and then that's how you discover something novel, right? So this was I wanted to show. This was how the 3D structure looked in the case of AlphaFold that we saw in our video. The predicting the 3D structure. This is the AlphaFold paper that's there. That can, if you go here, you can just get the 3D structure of any molecule. Yeah, and this is the paper by DeepSeek, where it's using reinforcement learning from experience for mathematical reasoning. This came out, I think, 2 weeks ago. DeepSeek Prover V2. So learning in the era of experience is happening already. We are already seeing traces of it, and this is how the future will be. So yeah, that's it. That's all I have for this huge series. I hope you learned a lot, and I'll see you in the next one. Thank you. Bye.